2. So I'm going to have 2 times 2 square roots of 2. What do I do to the outside numbers? Multiply them. So we're going to have 4 square roots of 2. Now, that is completely valid. On the other hand, I had someone say that 16 is a factor of 32. So 16 times what is 32? 2. So if I break this down, what is the square root of 16? 4. So I'm going to have 4 square roots of 2. So it does not matter if you do the highest factor or a lower factor, but when you pick smaller numbers, you always want to double check the other number that I'm using, does that have a factor that is a perfect square or a perfect cube? Because if it does, you have to keep going. Now notice, we got the same answer either way. It doesn't matter if I picked 4 as my starting value or 16 as my starting value. I still get the same thing in the end. And so as long as you are simplifying completely, we don't care which way you go. So either one works. Now, when it comes to cube roots, there is the potential for negatives. Now, whenever I had a negative and it was a square root, what did I have to have as a part of my answer? I. When you come in, and just as a side note for this, when you come in and you take the cube root of -1, and this is a cube root specifically, that is equal to -1. It's not an I, it's not an imaginary. If you take -1 times -1 times -1, you're still going to get -1. So this is one where if you have a cube root, don't automatically make it imaginary just because it's negative. So kind of ignoring the negative for now, is there a factor of 24 that is a perfect cube? Look at your list of perfect cubes at the top. Which one of those numbers is a factor of 24? 8, right? We're looking at the cubes, not the squares. So we're going to have cube root, and you can kind of put this into pieces. I'm going to write this as -1 times 8 times 3. Because -1 times 8 times 3 is -24, correct? So then we split it up. Now, a lot of the time, if you remember, when we actually started doing this quite a bit, we didn't have to write this middle step where I separate it all into cube roots. If you want to, and that helps you kind of space things out and see that you're taking the cube root of everything, absolutely. But we don't require this step. Now, we said the cube root of -1 is -1. What is the cube root of 8? 2. And then we have the cube root of 3. Your last and final step is going to be any numbers that you pull out of the radical, they get multiplied. So this would be -2 cube roots of 3. So we've kind of covered that stuff before. Now for a variable, these are kind of like our intro steps. Do you have a question? Which question? The 3 did not become a 1. Well, so 3 is not a perfect cube. That's why. With number 3, just kind of reiterating some things. If you don't see a number here, this is the index. It's a 2. If there's a blank there, it's 2. Now what I'm going to do is I'm going to kind of write this out in a long form. When I have x to the power of 5, what's really happening there? X times x times x times x. So I really have x, 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 right? Now, whenever we're going in and we're taking a square root, you're looking for pairs of things that are being multiplied. So I'm kind of counting how many pairs I have. So I have one pair of x's and I have another pair of x's. That's going to tell me how many x's come outside. You're pulling the pair out. And just as an intermediate step, if this is like, what the heck, how did that happen? Think of this like x squared times x squared times x. What is the square root of something that is being squared? What happens to those two things? They cancel out. So it's kind of like this is becoming x times the square root of x, because those things cancel each other out. And if you have something left over that's completely by itself, it stays inside the radical. So we're kind of pulling out these doubles whenever we're dealing with the square root. Now, we said, if you have anything that's being pulled out, what do we do to it? What do we do to the two x's on the outside? We multiply them. So we're going to get x squared square roots of x. You always, in order to know if you are completely simplified, your index, your root, this number needs to be bigger than the exponent on the inside. So 2 on the outside from the radical is bigger than an exponent of 1 on the inside. And that's how you know I am completely simplified. Got a question, Leah?
Why did you pull out like 2x's instead of 4?
So when I go in, think of it like this. When I'm taking the square root of x squared, right? The square root and the squared cancel, and you're left with just an x. So by taking the square root of that double, you're only pulling out one of them. So it's always going to cancel out. Okay, do I have any other questions? Now, I'm going to kind of show you another way of thinking for this problem because it might make life a little bit easier. So we have square root of x to the 5th. The way that I think of this, there's going to be something inside and there's going to be something outside, most likely. So how many times does 2 go into 5? 2 times, right? 2 goes into 5 twice. So that means I'm going to pull 2 out. And then if I did 2 into 5, what would be left over? What's my remainder? 1, right? So I'm going to have 1x on the inside. So 2 goes into 5 twice with 1 left over. So a lot of the time we treat this almost like division, and you're taking your index and dividing your exponent. So 5 divided by 2 gives me 2 with a remainder of 1. So that sometimes is easier for people to realize than I'm taking a bunch of x's out and x's are staying in. Now, this is the first example. We will do a couple more where it should hopefully solidify. But I personally think asking yourself that question of how many times does this number go into this number is a little bit easier. So let's try another one. Let's go here. Again, if you don't see a number in the radical, the index is 2. Now, we're going to take this piece by piece. How many times does 2 go into 5? Twice. So I'm going to have x to the power of 2, and then does it go in perfectly? No. What's the remainder? X. So I'm going to have x to the power of 1. Okay, x is taken care of. Y. How many times does 2 go into 7? 3. So I'm going to have y to the power of 3. Does 2 go into 7 perfectly? No, right? 2 doesn't go into 7 perfectly. It has a remainder. What's the remainder? 1. So I'm going to have y to the power of 1. Now, does 2 go into 6? How many times? 3. Is it perfect? Yes. So do I have to put anything inside if it divides perfectly? No. So I'm just going to have z to the power of 3. And this is my answer. So if your exponent divides perfectly, you don't have to leave anything in the radical. You will not have anything left over. Yes, Isabella? No, you don't have to have the 1 in the 1. If it was like 2, yes, but 1 you don't have to. I just want to make it clear that it's 1 because there's 1 remainder for both of these. Okay. Not right now. Okay, do I have any questions? Sweet. Let's go to number 5. Now, if you have a number on the outside that is going to be something where you don't do anything with it. You leave it alone, don't touch it for now. I'm going to deal solely with, Gabriel, stop. You're going to deal solely with the exponent for now. With the radical for now. So first thing that I like to do, because I know sometimes the number is the hard part and the exponents with the variables really isn't the challenging part, I'm going to go in and I'm going to figure out what the cube root of 16 is before I do anything else. Is there a factor of 16 that is a perfect cube? Cube, not square. Which one? 8. So I can rewrite this as the cube root of 8 times 2. What is the cube root of 8? 2. So I'm going to have 2 cube roots of 2. Now, personally, you guys are a lot better with the variables of this than the numbers. So that's why I kind of like to do this on its own and then kind of just loop it back in at the end. So let's go in and let's focus on the variables this time. If I have cube root of a squared b 12, does 3 fit inside 2? No, if it does not fit in at all, you don't do anything. You leave it alone, you don't touch it. I know that a to the power of 2 has to stay inside the radical. If the outside number is bigger than the inside number, you cannot simplify it anyway. Now, does 3 go into 12? How many times? 4. So I'm going to pull b to the power of 4 outside. Do I have any questions so far? Now, I'm going to kind of take the things that I've simplified and combine them together. I know that I have a 3 at the front. I said a 2 is at the front, and I said a b to the power of 4 is at the front. All of those things get multiplied. So I'm going to multiply all of them together. So I'm going to have 6b to the power of 4. Yes, Alondra. Oh, it's okay. I'll get it in a second. 6b to the power of 4. Now, on the inside, everything that is inside the radical is going to get multiplied, but you really just write it. Let's see. They may just send somebody with a pass. Hi. Yes. Yes, I can. Christian, you're getting checked out. Thank you. All right, 6b to the 4. And then on the inside, I'm going to take everything that I simplified, the 2 and the a squared, and that will be written inside. 2a squared. Oh, I'll get it. Hold on. Now, I did this in pieces. You don't have to do it in pieces. I did it. Christian, go.
Here, what? No?
So I took the numbers separately from the variables because sometimes it's easier to do it in 2 parts versus all at once together. But you don't have to do it that way. You could absolutely just treat it as one big problem and simplify as you go. Something I want you to know is all of this is really hinging on, do you know your perfect squares and your perfect cubes? You have to know them. Yes, Leah? Because we pulled a 2 out when we simplified the cube root of 16. 6b. It's 6b, not 2b. What's 3 times 2? 3 was originally outside. We pulled a 2 outside for the 16. And there's a b to the power of 4. 3 times 2 is 6. Okay, any other questions? All right, let's go on. Because we are changing directions. Okay, when we are adding and subtracting radicals, it is kind of like combining like terms. If your radical does not look exactly the same, you cannot add or subtract them. So what I want you to notice is in my first example, I have a 4th root of 7. Gabriel, quit talking while I am talking. Stop. I will sit you outside. 4th root of 7. And so with those 4th roots of 7, all I have to do is simplify the numbers in front. What is 3 minus 5? -2. So I'm going to end up with -2 4th root of 7. That is my answer. You don't do anything to the radical when you are adding or subtracting. Think about if I had 3x squared minus 5x squared, you don't turn that and cancel out the x squareds, you just make it -2x squared. So it's all just dealing with like terms. They have to be identical to each other. So combine them, simplify them, and then you're done. Now, one thing that does sometimes happen is you get problems where you have cube roots and square roots. They have to be identical before you can do anything. So I'm going to go in and I see that I have a square root of 15 and I have a square root of 15. That means that those two terms can be combined. I have a cube root of 21 and a cube root of 21. Those two terms can be combined, but I cannot combine them with each other, like separate, like with the cube root and the square roots. They have to be identical. So what is 8 plus 12? 20. Square roots of 15. What is 7 minus 4? 3. So we're going to have plus 3 cube roots of 21. And that is going to be your final answer. It should be easy. Now, whenever you look at number 6 and number 7, everything that's in the radical cannot be simplified. There's no perfect squares that are factors of 15. There's no perfect cubes that are factors of 21. Those are things where I couldn't do anything to the problem. However, when we look at something like number 8, there are radicals that we can simplify. 50 has a perfect square that is a factor. 18 has a perfect square that is a factor. And 32 does as well. So we have to simplify when we can. So when I look at 50, what is a factor of 50 that is a perfect square? 25. So 25 and 2. When I look at 18, what is a factor of 18 that is a perfect square? 9 and 2. Now, just a hint and a tidbit. If you're doing a problem like this and you notice, oh, I have 2 of them that are being multiplied by 2, most likely when you get to that third one, there's going to be a way of writing it where it's using a multiple of 2. How would I write 32? 16 and 2. So one way that we typically write these problems is so that they eventually in the end can all get combined together. What is the square root of 25? 5. What is the square root of 9? 3. And I cannot take the square root of 2, which is why I'm leaving it in the radical. And what is the square root of 16? 4. And remember, any number that you're pulling out of the radical is going to get multiplied with anything that is already there. So I'm going to do 5 times 5, 2 times 3, and 9 times 4, because there was a number already in front of my radical term. So I'm going to end up with 25 square roots of 2 minus 6 square roots of 2 plus 36 square roots of 2. And typically for these problems, you're going to have something to combine together in the end. They all have the same radical. They all have a square root of 2. So if they all have the same radical, all you're doing is combining the numbers in front. So personally, I think doing 36 minus 6 first is easy. What's 36 minus 6? 30. What's 30 plus 25? 55. So I'm going to have 55 square roots of 2. What do you mean? I know, but they all have the same term. So when I combine the number in front, it's like combining all of those terms together. So it's like we have 25 square roots of 2 and we have 36 square roots of 2. So you have a bunch of them all coming together. Okay, let's try the next one. Let's go to the back. Now, when you multiply radicals, you are going to take the outside terms times the outside, and then you are going to do the inside times the inside. Do not mix and match. It's outside, outside, inside, inside. Whenever you don't have anything outside, you don't have to write anything. So our first example is just square roots. So I'm not actually going to do anything with it. I'm just going to get going with multiplying the inside times the inside. So what happens if it was in a radical originally, in a square root? It's going to stay there for now. So what's happening is we are coming in and we're taking 3d to the power of 11 times 48d to the power of 7. Now, sometimes, just as a little tip, it's easier to simplify them separately and then combine them together. But in this case, it kind of works either way. I actually am going to kind of take this in different parts. 48 is the same thing as 16 times 3, right? Hopefully. Yes, 16 times 3 is 48. So before I do anything, I kind of want to write those numbers together so I can deal with the whole number part. So I have 3, I have 3, I have 16. Now, I'm only doing it this way because I want you to see, I don't know what 48 times 3 is. I'm sure I could figure it out. 24, 144, that's not terrible. 144, am I right? 48 times 3, 24. Oh, let's leave it as 144. That might be easier before we overcomplicate our lives. Now, when I have exponents, and this is like pulling back from all the way to Algebra 1, and you are multiplying them, because right now I'm doing d11 times d to the power of 7. If I have exponents and they're being multiplied, what do we do to them to combine them together? We add them. So one little reminder, if I have x to the power of a and I have x to the power of b, that's the same thing as x to the power of a plus b. This is a rule way, way back, Algebra 1, that you learned where you were simplifying exponents. So when I see d to the power of 11 times d to the power of 7, I need to add those two numbers together. What's 11 plus 7? 18. So I'm going to have 144 d to the power of 18. Now here is where we start to actually simplify, because you will be expected to simplify completely. If you don't see a number, it's a 2, it's a square root. Can I take the square root of 144? What is the square root of 144? 12, which makes our life a whole lot easier than what I thought it would be. Okay, now does 2 go into 18? How many times? 9. Does it go in perfectly? Yes. So it doesn't divide with any remainder. So my final answer, and that is a 9, is going to be 12d to the power of 9. Okay, so that is if you have radical times radical. Now, whenever I'm distributing, I have to pay attention. You're not going to distribute when you just have radical times radical. The big important thing to notice for number 10 is that there is a minus sign in between 2 and minus 3 square roots of 6. So that means that I have to come in and take this outside term, the 4 square roots of 6, and I have to distribute. The only time you have to distribute in this way is if you have addition or subtraction. So we have subtraction, so we're going to have to distribute. So what I'm doing, just because I want to separate it into two things so you can kind of see what's going on, I'm doing 4 square roots of 6 times 2, and then I'm going to have separately minus 4 square roots of 6 times 3 square roots of 6. So I distributed to both things. Now, for the term in red, the 2 itself does not have a radical. So whenever I multiply those two things together, I'm really only looking at 4 times 2. What is 4 times 2? 8. 4 times 2 is 8. So we're going to have 8 square roots of 6. Now, again, that is because there is no radical currently attached to the 2. So it's just multiplying the numbers in front. Technically, you could probably think of this as square root of 1, which if I multiply 6 times 1, it's still 6. So it's not really changing anything. Now, when I go to the second term, I do have outside numbers and I have inside numbers. I have an outside number of 4 and an outside number of 3. And I have inside number of 6, inside number of 6. So I'm going to multiply the outside ones together. And I'm going to get minus 12. And I'm going to multiply the inside ones together. And I'm going to get square root of 36. Now, before you try to go in and subtract the 8 and the negative 12, these two radicals do not match. They cannot be combined together unless they match. So what can I do? Square root of 36. What is the square root of 36? 6. So I'm going to have 8 square roots of 6 minus 12 times 6. And what is 12 times 6? 72. And I'm going to get the question, what if I write negative 72 first and then do plus 8 square roots of 6? Same exact thing. Does not make a huge difference as long as they are the right number with the right sign. Okay, do I have any questions so far? Mostly just distributing today. Let's go in. Let's try number 11. So this is going to be a double distribute. We are going to FOIL first, outside, inside, last. If you like box method, you can do box method, whichever way is good for you. So I'm going to do my first terms times each other. There's a 2 on the outside, a 2 on the outside. So that's going to give me a 4. And I have a 6 on the inside and a 6 on the inside. That's square root of 36. I'm not going to come in and simplify anything until the very end. So then I'm going to go to my next one. 2 square roots of 6 times 4 square roots of 3. So outside times outside is going to give me 8. 2 times 4 is 8. Inside times inside, I have 6 times 3. So that's going to give me 18. Is everyone with me so far? No questions. What are you confused about, London? Okay. Any other questions so far? I'm literally just multiplying radical times radical, radical times... What do you need from Isabella? Okay. Inside times inside. We're going to go in and we are going to take negative 4 square roots of 3 times 2 square roots of 6. So I'm going to have negative 8 square roots of 18. And then I'm going to do the same thing for the last term. This is like we are double distributing with binomials. It's just you have radicals instead. -4 times +4 is -16. And then I have square root of 9. So outside, outside, inside, inside. That's all I'm doing. This is convenient enough because what happens to our two middle terms? They cancel out. I have a +8 square roots of 18. I have a -8 square roots of 18. So those of themselves are going to cancel each other out. Now, we said the square root of 36 was 6. And if I'm going over here, 16, the square root of 9 is 3. So all I have to do is combine these two things together. What is 4 times 6? 24. And we've already said that 16 times 3 is 48. And anything that you get in the end that is just whole numbers, you just simplify it. What's 24 minus 48? -24. There we go. So sometimes with these radicals, you end up with just a number answer. And we're going to do this again in just a second. So if this was a little weird, we're going to try it one more time. For number 12, don't do this because this is going to be bad math and this is going to be something that people will make the mistake of. A lot of people see this and they want to take this squared and they want to distribute it and cancel out the square roots and get 3 minus 5 and say that it's -2. You cannot do that. That is bad math. That is bad algebra. Because when you see a squared, that is the same thing twice. So what I'm really looking at is the square root of 3 minus the square root of 5 times the square root of 3 minus the square root of 5. And so I have to go in and I have to double distribute just like I did with number 11. So I'm going to do everything multiplied by everything. So I do first, so square root of 3 times square root of 3. Remember, if there's no numbers on the outside, you don't put anything outside. I have a 3 on the inside and a 3 on the inside. That's going to give me square root of 9. I'm going to do the outside terms. That's going to give me a minus square root of 15. Now, this one does not cancel out like the last one did because I'm going to get another minus square root of 15. They don't always cancel each other out. And then for the last multiplication, what's a negative times a negative? A positive. So plus square root 25. So when you get to this step, I will say when we grade questions like this, we give you points. Like, did they do 1, 2, 3, 4 correctly? That's good. And then our goal is for you to start combining things together. What is the square root of 9? 3. And then I have 2 square roots of 15. So I'm going to say minus 2 square roots of 15 because they are the same radical and I'm combining them together. So I have a -1 and a -1. If you need to, you can always put a 1 at the front. And if I do -1 plus -1, that's where my -2 is coming from. What is the square root of 25? 5. What numbers at this point can we combine together? The 3 and the 5, because they don't have a radical attached to it. So I can get 8 minus 2 square roots of 15. And before you want to go in, because I know the common mistakes, a lot of people want to do 8 minus 2 is 6. It's 6 square roots of 15. You cannot combine these two terms together because they don't look the same. They don't have the same radical. If they were both square roots of 15, sure, you could combine them together. But 8 is a single number and the 2 has a square root of 15 attached, so they cannot be combined. Leave them alone, keep them separate. Okay, last one for the day. This one is going to be the more Algebra 2 Advanced problem of the day because it requires a little bit more work. Now, Same exact idea. I'm going to take the easy part. 3 times 3 is 9. And then I'm going to distribute again. 3 times the square root of y minus 2 is 3 square roots y minus 2. Inside, another easy one. 3 square roots y minus 2. Where people typically get kind of mixed up and kind of weird is when I come to this last term where I'm taking the square root of y minus 2 times the square root of y minus 2. I'm going to write this in multiple steps, but once you kind of see what's going to happen, you don't have to write every single step. This is like I'm coming in and doing y minus 2 times y minus 2. Please do not distribute this. Don't do it. It's going to cause you more trouble than it's worth. Whenever we're taking the same term and we're multiplying it by itself, another way that we said we could write this is as if that item or expression is being squared. This line at the top, the blue part, is equivalent to what's directly underneath it. Y minus 2 times y minus 2 can also be written as y minus 2 squared. What happens when you take the square root of something that is being squared? They cancel each other out. So what happens is this square root and this squared cancel each other out. So I end up with 9 plus 6 square root y minus 2, because I'm going to combine those two middle terms together, and then I'm going to have plus y minus 2. You no longer need the parentheses because those two things don't have to stay together once they're out of the radical. Now, are there any terms that I can combine together with what I'm looking at? The 9 and the negative 2. What's 9 minus 2? 7. Now, the order that you write these in does not really matter. As long as they have the right term and the right sign, we don't necessarily mark it wrong if you put the y at the front or the y at the end. But this is going to be a stepping stone because you will need to know how to do this when we start solving next class period. So, just a little heads up, you have a quiz next class period. So it will cover 6.1 and 6.2. Quiz next class period. You will have a test on Monday the 26th, I believe is what the date is. That's the 19th, the next Monday. Not this Monday, the next Monday. Oh, happy birthday. Take a test. Yes. It's like the third week equivalent. 2, 3. There you go. 4. I will take it off in just a second. I haven't gotten to my desk yet.
Can I go to the restroom now, please?
Can you put a pass in the system when I undo Go Guardian? Can you put a pass in the system? Can you put a pass in the system? I'm going to take it off right now. I'm going to take it off. I have barely got back to my desk. Let's see.
Phones.
Mm-hmm.
Apparently, whoever collects the most phones